So see some more questions today. So this is naphthalene. Naphthalene is reacted with this reagent first in the presence of anhydrous aluminum chloride. Then the product obtained is heated with concentrated hydroxide, and after that acidification is done. You have to find the product of the reaction. Try to do it.
Sir, is it like benzylic acid rearrangements?
Correct.
Yes, sir.
You got it?
Yes, sir.
Yes, sir.
So first reaction, you must have identified what reaction it is. First one.
First one is assigned,
Yes.
sir.
Which reaction is?
Yes.
Yes reaction. So here, this is Friedel-Crafts acylation. Now this is naphthalene, and just few days back, probably day before yesterday, I discussed that ES reaction on naphthalene. where the electrophile will go?
Alpha position, sir.
At alpha position. Temperature is not mentioned. So if temperature is not mentioned, we will take room temperature and then electrophile will go to alpha position. So here, when this is reacted with this compound, ES reaction is going to happen. And first you will get this product. This you will get. ES reaction will take place at alpha position. Now see this product which you have got. This is 1,2 diketone. So this reaction is ES. Now after that you got 1,2 diketone. Now this 1,2 diketone is heated with base. Just to try to recall this reaction. Whenever 1,2 diketone is heated with base, one name reaction which is known to you that takes place, and that name reaction is called as benzylic acid rearrangement. So this benzylic acid rearrangement will take place now. Now this OH minus will attack on carbon atom of one of the ketonic group and pi bond will move to oxygen. Then you will get this product here. First this will be formed and after that a rearrangement will take place. In this rearrangement, this negative charge on oxygen that delocalizes between oxygen and carbon, and then one alkyl group from this carbon migrates to next carbon. Here, in the place of alkyl, this phenyl will migrate, means this bond will be shifted here. Yes. Migration of this ring will take place from this carbon to next carbon. That is only benzylic acid rearrangement. So this carbon-carbon bond will break and new bond between this carbon and this carbonyl carbon will form. Then you will get this product here. Now see here, when this phenyl migrates to this carbon, this pi bond will get shifted to oxygen. So here this oxygen will have negative charge and there will new bond between the two carbons. And this bond will be broken. And after that, the next step is known to you. There will be internal proton transfer. This O minus will take H plus from here. So it will become OH. Here you will have negative charge. It will become CO, O minus. Then finally, when you do acidification, that COO minus will also become COOH. So I will write directly. But again, I'm telling the mechanism is known to you. This O minus will take this H plus. There will be internal acid-base reaction. This will become OH and this will become COO minus. Then when you add acid, that COO minus will become COOH.
Sir, we can do decarboxylation also.
So this is the product. Yeah. Anyone asking anything? Someone was asking something. Did not listen properly.
Sir, can we do decarboxylation?
Decarboxylation. How?
Last step had heating.
When will you have decarboxylation? What is the condition for decarboxylation? It should be beta keto acid, right? Do you have beta keto acid here?
Even unsaturation can have.
Unsaturation can happen, but you see this unsaturation, that is basically because of the presence of that carbon-carbon double bond, carbon-carbon triple bond. That can happen, right? Here you must have thought that there is unsaturation at this beta carbon. It's fine, but you see, if you read this complete question, this part complete reaction is what this. After first reaction was ES. After that, what is the next reaction? Next reaction is benzylic acid rearrangement, and that H plus which we are adding in the last step. That H plus is basically for what? That is only for protonation, and heating we have done here. This was the heating we have done. In the last step, we are not doing heating. We are simply adding acid. We have heated and we got this product, and after that simply we have done acidification. So you should not think about any decarboxylation. That
Okay.
H plus is only for protonation.
So if we have decarboxylation, then can we do if we have heating in the last step?
Yeah, if heating is there, then if there is unsaturation, it happens. But you see, you have to read the complete question and you have to understand what is the meaning of the given reagents. Right here, in the question, they have simply asked benzylic acid rearrangement. So the last step, the H plus which is added there, that has been added just to acidify the solution.
Yes,
Obviously, if
but I'm asking.
At beta carb position, if unsaturation is there, then on heating the decarboxylation can happen.
Yes.
The degree of unsaturation in A is X, degree of unsaturation in B is Y, number of rings in A is Z, and number of rings in B is P. So written here number of rings in A and B at Z and P respectively. Then find the value of this Y plus P divided by X minus Z.
So 2.
2, exactly 2.
Yes.
Once you check, I don't think it is exactly 2. It will come in fraction.
So 5 by 3.
5 by 3. Check again.
So is it 4 by 3?
4 by 3. That is also not correct.
7 by 4.
I think it is coming 1.8. Final answer is
9 by 5.
1.8.
1.75.
Sir, 9 by 5. 1.5.
9 by 5 should come. All could do it. All the reactions involved in this question are very common reactions. Are you getting 9 by 5?
Yes, sir.
Yes.
Okay. So orthoaminobenzaldehyde is heated with acetone in dilute sodium hydroxide solution. So we have taken orthoaminobenzaldehyde. So this is orthoaminobenzaldehyde. It is heated with acetone in the presence of dilute sodium hydroxide. Which reaction is this?
Aldol reaction.
This is aldol reaction, and it is heated with dilute sodium hydroxide, so that aldol which will be formed, that will be dehydrated also, and directly you will get alpha beta unsaturated carbonyl compound. So the product of this step will be this one. Dehydration will happen, and if you dehydrate that aldol, you will get this product. This will be alpha beta unsaturated carbonyl compound. So this first reaction is over. The major product A, this is your A. Now after that, it is said that this product A on treatment with catalytic amount of sulfuric acid produces another major product B. So now it is reacted with catalytic amount of sulfuric acid. What reaction will happen here?
Ammonia group and CO will react to give C double bond.
Right. So that is the simple reaction of addition of ammonia derivative on carbonyl compound in the presence of acid catalyst. You know, addition of all ammonia derivatives on carbonyl compounds is acid catalyzed reaction. So this is catalytic quantity of acid. Here is the ammonia derivative and here is carbonyl group. So just addition will happen, and all of you know how to do this addition. Just you need to remove this H2 and this O in the form of water and connect this nitrogen and this carbon by a double bond. So this was the product, and this is another 6-member ring. 1, 2, 3, 4, 5, 6. So this is another 6-member ring. And at this carbon, we have one methyl group also. So this is your product B. Now, degree of unsaturation in A is X. So this is A. Just to count the degree of unsaturation, 3 pi bonds here. So 3 and 1 ring. So 3 plus 1, 4. This pi bond 5 and this pi bond 6. So degree of unsaturation in A is 6. Now degree of unsaturation in B is Y. So Y is degree of unsaturation in B. Here you have this side benzene ring. So 3 pi bonds and 1 ring, 4. Here you have 2 pi bonds, so 5, 6 and 1 more ring structure, 7. So degree of unsaturation is 7 here. And number of rings in A is Z. So Z is the number of rings in A, that is 1, and P is number of rings in BY. Here in B you have 2 rings, so the value of P is 2. And after that you substitute and calculate, you will get 9 by 5.
So
Yeah, tell.
after aldol condensation reaction, sir,
Yeah.
can't NH2 directly attack as a nucleophile? Can't it attack C double bond also, like on the carbon, sir? Because
That
even then
only
it will form.
this nucleophile that is only attacking on the C double bond owner. This is the
Yes, sir.
addition of ammonia derivative on carbonyl compound. How this reaction happens? When you add acid catalyst, first this oxygen gets protonated. It becomes OH plus. And then this nucleophile attacks on this carbon and pi bond moves to oxygen.
Okay,
That's
sir.
why this addition happens. So
So
mechanism is
without that catalyst, it cannot happen, sir.
no. This addition of ammonia derivative always needs acid catalyst. And here this reaction takes place in certain pH range. You need to maintain the pH of the solution also.
Yes.
Can anyone tell what is the pH range?
4 to 5.
4 to 5. So in the left hand side, I have written all reactions, and in the right hand side, I have written some tests and reactions which the products of these reactions PQRS can give.
Sir, should we consider all products and see if they are giving the test, sir?
All product means?
For example, in R, sir, we'll have two products. No, sir. Then
If you're having two products, you should count for both.
okay, sir.
Sir, Q25. P25.
Completed?
Yes, sir.
Yes.
Yeah, tell for P
2-5.
25.
Q4.
Only for
Only for
Only 4. Okay.
1-2.
1.
1-2.
1, 2. Yes.
3-6.
3-6.
3, 6.
3.
The given answer is 2, 5, 4, 1, 2, and 3, 6. So whatever we have written here is correct. If anyone wants any of the options to be explained, please tell, I will do that.
What's the product in first reaction?
Product in first reaction. So first this ketone is reacted with MCPBA. Which reaction is this?
Bear
Baeyer-Villiger reaction. So what will happen here? You will get ester. So first you will get ester. I am writing here. This you will get first. With MCPBA, you will get this cyclic ester. Baeyer-Villiger reaction will take place. And after that, you are adding dilute sulfuric acid. This ester will undergo hydrolysis. So this ester undergoes hydrolysis. What will you get? You will, this bond will break, and from this side you will get carboxylic acid. So this C double bond O will transform into carboxylic acid, and this O will become OH. OH group. So if you have carboxylic acid group, that will respond to this sodium bicarbonate test, and if you have OH group, that will respond to this steric ammonium nitrate test, CAN test. Have you got it?
Yes, sir.
Sir, what is the sixth test, sir?
What is?
The sixth test.
Sixth test. Do you remember that Hoffman's mustard oil reaction, which I taught in amines?
Yes, sir.
Yeah.
Yes, yes.
So,
Okay. Yeah, secondary amine.
This comes in that only. If you have primary amine, the product will give that black precipitate with mercury chloride. If you take secondary amine there, it does not give. So whatever thing is written here, this is for secondary amine.
Yes, sir.
And you know this isocyanide, if isocyanide is reduced with sodium in alcohol, what product will you get?
We get CH3, NHCH2, CH3.
Right, so dimethylamine you will get.
Yes, sir.
So that is secondary amine.
Yes, yes.
So this will match for secondary amine. If primary amine is the product, then primary amine will give that black precipitate with mercury chloride. Secondary amine does not give. And
Yes.
this 3 will also match for secondary amine only. You know, primary amine forms a product with Hinsberg's reagent which dissolves in potassium hydroxide solution. But secondary amine forms a product with Hinsberg's reagent that does not dissolve in potassium hydroxide solution. Okay, suppose in the place of secondary amine, if we take tertiary amine, what is the reaction with Hinsberg's reagent?
Amine salt will form.
I'm asking the reaction of tertiary amine with Hinsberg's reagent.
No reactions.
No reaction. Tertiary amine does not react with Hinsberg's reagent. Primary amines react with Hinsberg's reagent and the product which is formed that dissolves in potassium hydroxide solution. Secondary amine also reacts with Hinsberg's reagent, but the product which is formed that does not dissolve in potassium hydroxide solution, because in that product we will not have any acidic hydrogen. And tertiary amine does not give any reaction with Hinsberg's reagent. Any other? Which reaction is this? R?
Gabriel thalmate synthesis.
Gabriel thalmate synthesis. I am writing one more matching. This is very easy, just to check your memory power. do it.
So 4, 5,
Yeah, tell.
4, 5, 1, 2, 3.
Next is 1, 2, 3.
Yes.
Okay, next
2, 3, 4.
2, 3, 4. Next
And then only once.
only one.
1 3
1 or 1, 3.
1 3 sir.
1, 3.
Sir,
Oh.
cellulose
3 sir.
cellulose has both,
So
no, sir, amylopectin and then we can't say it is linear.
That is starch now. Amylose and amylopectin is starch.
So that's why I told you that to check your memory power. You forgot it. That amylose and amylopectin are not cellulose. They are in starch. Cellulose is linear polymer of beta D plus. Cellulose is linear polymer of beta D plus glucose, right?
Yes, sir.
Yes, sir.
So among all these, bakelite is the only polymer which is not linear. You know, bakelite is that branch chain polymer, and basically this bakelite is we call that as one special kind of polymer that is called as cross-linked polymer. That is a kind of branch chain only. So, but anyway, that is not a linear polymer at all. So bakelite is not a linear polymer. Remaining all natural rubber, this buna N, this is also called as NBR, nitrile butadiene rubber, cellulose, all these are linear polymer. Bakelite and cellulose, these two are condensation polymers, but this natural rubber and buna N, these two are addition polymers. Thermosetting polymer is only bakelite. That is the only thermosetting polymer here. After that, remaining all you have got. If anyone wants to ask anything, you can ask. Okay. Now, one more question I will write.
Sir, ABCD, sir.
ABCD.
Yes, sir.
What is the final product here?
You get 2 cyclohexane rings and on one of the
It's on bridge.
Bridge carbon on OH.
It's something like this.
yes, sir.
Yes, sir.
So this is the final product of the reaction, and answers are A, B, C, D. All will give the same final product.
Sir,
Yeah.
in the first and third A and C options, if you do ring expansion, it is changing from 3 degree to 2 degree carbocations. Should we still do it?
3 degree changing to 2 degree.
Yes.
Have you checked it?
Yes, sir. We are doing 2 times ring expansion, sir. First it changes to 2 degree, then it changes again to 3 degree.
Here in option A. This you are getting, right? And after that,
How is that happening, sir? It should join that carbon oil.
okay, this big.
No, sir. The carbon will get positive charge.
No, this carbon is getting positive. Here, this one. Correct?
Yes, sir. This is a 2 degree carbocation also. Will still happen. And hyperconjugated structure is also 2 only.
Sir, but then we won't be able to do ring expansion in any other case. Except when it is primary.
Whenever this is a case, it should not happen actually. This is logically wrong. This is tertiary. And if you expand this ring, it is becoming secondary. Then this step is not correct. After that, again, if you expand, then it will become tertiary, right? Yeah. But this expansion itself is not correct. This is wrong.
Answer should be PD, no, sir.
So given answer is not correct. Okay. I've taken from one of the IIT's papers directly. I have also not checked. Yes, given answer is not correct. Whenever this is the case, actually the driving force for this ring expansion is increase in stability of carbocation. That happens only when the stability of carbocation increases. And it should increase in every aspect. It is not like that after second expansion it will again become tertiary. From here to here it will proceed only when the stability increases. This step is logically wrong.
So, if you
Yeah,
have a secondary carbocation, can we do rearrangement for a secondary carbocation to convert it to another secondary carbocation, or is that also not feasible?
Tell again.
So if I have a compound where there's a secondary carbocation, and I do ring expansion to form another compound which has a secondary carbocation, is that possible, or is that also not possible? Like,
But you have to compare the stability of those two carbocations. So after rearrangement, whatever carbocation we have got, that should be more stable than the previous one.
okay.
Suppose if the secondary is transforming to secondary, but there is some other stabilizing factor which is stabilizing that new carbocation more, then that will happen. The only one thing you have to keep in mind that in each and every step of rearrangement, stability should increase. The stability of the carbocation should increase. If it is not increasing, then that step is impossible. That does not happen.
Okay, sir.
Sir?
Yeah.
Sir, is there any limit on how many times can we do hydride shift and ring expansion for any carbocation?
There is no limit, such limit. There is no such limit.
Okay.
Then what is the answer for this question, sir? We are getting two options of same compound, two options of other compound, sir, which are same. Means
Okay,
what should be the answer?
then this question has a problem.
Yes.
Because, B and D are having same, right?
And A and C are having same, sir.
And then this question has problem. We can't do anything. This question has problem.
Yes.
Actually, I think that person who has given this question, he has done this rearrangement this way, and after that he made the same product. So that question is not correct. Okay, right. So closing now. We will meet in the next class again.